Hello and welcome back to the Inside Java podcast, a podcast about everything Java brought to you from the team at Oracle who makes Java. My name is Ana Maria Mhelceanu, and while at Devoxx Belgium 2024, I spent some time talking to Viktor Klang about stream gatherers. Viktor is a software architect in the Java Platform Group at Oracle, but has focused for a long time on enabling developers to solve problems with maximal productivity without sacrificing maintainability. Viktor and I had a conversation on the feedback from the community on the stream gatherers, its applicability in the daily development, tips and tricks to working with gatherers, and more. So let's get right to it. Viktor, it has been a little over a year since stream gatherers have been introduced in public conversations. I think that there was also a presentation here at Devoxx Belgium. However, can you please recap a bit on what stream gatherers are and why we need them?
Sure. So the stream gatherers is an attempt to create an abstraction for letting users create their own intermediate operations for streams. And it had been a very long-standing feature request, and it was not really certain how we would go about it. We have Collector since before that allows us to create these custom terminal operations, but creating custom intermediate operations is much more difficult to get right. So I spent quite a bit of time trying to figure out what the right API would be, making sure that you can implement everything that you would want to implement using it. And I essentially ended up implementing the entire stream interface with gatherers just to prove to myself that this was really going to work. So it allows you to create your own intermediate operations for streams. And the JEPs, so it's 461, 473, and 485, allow you to do this and gives you a couple, like 5 built-ins that you can use. So it augments the capabilities of stream. And we do this because at the end of the day, if the stream interface were to get all of the useful operations in the world, you would have hundreds of methods and you would never find anything. So we need to make sure that you can do what you want, but still let the stream interface stay nice and tidy.
Yeah, we also have to think about the cleanliness of things. Having options is good, and we're going to talk about options that we have with stream gatherers in a bit. But you mentioned that this feature has been iterated through several JDK enhancement proposals. So this feature has been already in 2 rounds of preview. Can you share a bit on the feedback it received from the community?
Yeah. So overall, I think it's been very positive. What I really wanted to get was usage feedback. Not just read the JEP or look at the interface, but try to implement your own intermediate operations. Does it work for you? What was difficult? And those were really important pieces of information that I received. So there are multiple sort of in the wild implementations of gatherers now, which I think is extremely interesting. And I think looking at the delta between what was originally proposed to what is currently there, I think it's about 1 or 2 bug fixes and a couple of documentation enhancements. So I would say that it was fairly stable, which is good. Means that I did my job right. I managed to get it to the point where people were able to be successful with it, and I always like getting feedback. That's how we can learn and improve. So if you're listening to this and you try it out, don't hesitate to reach out and let us know, even if it's just positive. That's good feedback as well. So it doesn't necessarily need to be that you found a bug or you couldn't do what you wanted to do, but just let us know that this is something that is useful, and we're happy for that.
That sounds really cool. And I'm going to dive a little deeper because you mentioned that we already have some options that are built in the API. So, I mean, I'm like any other developer. I love API utilities. So if they're done for me, it's perfect. So let's talk a little bit about working with the already existing built-in gatherers. I've seen more examples and people, blogging about their ideas with using the existing gatherers. So based on the feedback you got so far, but also your experiments, do you mind providing for us a couple of examples of when we could use these built-in gatherers and how those streamline other operations, like a comparison, like, well, before you would have done these many intermediate operations, or actually not intermediate operations, you would have done this filtering, then closing the stream, then opening the stream again, because that's pretty much what we all do as developers. When we got the Stream API, it was like, ooh, this cool thing that we can do a lot of things like open, close, open, close, open, close until it does what we expect it to do. So just give us some examples for our audience, like when the built-in gatherers can be used, like where do you see its most applicability, what do you aim to inspire with those?
Yeah, so a couple of things there. For myself and personally, my design goal here was to allow developers to stay within the stream that they've already opened until they were ready to execute the final or the terminal operation. So to avoid having people to run a stream, do something else, create a new stream, and do that. So that was one of the things. And I also wanted to make sure that we could support new and different operations with it. So some of the things that were missing in the stream interface was grouping or windowing functions. So that was one of the first things that I decided to take a stab at with gatherers. So in the gatherers class, where we host the utility gatherers, we have window fixed and window sliding. So if you want to create groups of elements in counter order on a fixed size basis, that's window fixed. It's really useful. But what turned out to be extremely useful as well is window sliding, because it turns out that it's fairly common that you want to compare the previous element with the next element. It allows you to do all kinds of interesting operations, especially things like stack traces. If you're walking the stack and you want to see where does this library begin or where does that library end, it's really useful to be able to compare the package name. So windowing functions, I took a stab at something called map concurrent. So streams has this either sequential or you're parallel. So that's one dimension. And then you have whether you're ordered or unordered. That's another dimension. But there was nothing in between sequential and parallel. And it would be interesting, I thought, to take a look at, okay, so you just have a single operation, but you want to run that concurrently. You want to create a smaller scope concurrent computation. So we have this map concurrent gatherer that allows you to specify how many at most at once or how many concurrently you want to be able to run. And you supply a function. So it's map, the operation, not the data structure. And you supply a function and a max number of concurrent invocation of that function. And then you can continue do other operations after that. So this map function will be called concurrently. And I decided to back that with virtual threads. So you don't necessarily need to worry about having thousands of potential platform threads being created. So that was an interesting take on what can we do with this thing that we might not have been able to do before. And I think, if I recall correctly, you also asked about how you envision the sort of the how you use it, right? One of the things that I've noticed is that a lot of people, stream the interface. When you have an instance of that, you can only perform one operation and that's used, and then you need to sort of keep building on this thing. But with collectors, those are reusable. So if you do collectors.toList, you can pass that collector around and reuse it. So I decided that I wanted to have the same behavior for gatherers, because if you have a gatherer, then you want to be able to reuse it. So you can return it and you can compose them into multiple ones. So I think that was an important aspect as well. So people can create these new operations and be able to use them in multiple places in their code without having to figure out how to obtain them in the first place. So you can create more complex behavior from simple building blocks. But yeah.
Yeah, when you were talking about collectors and grouping, I was thinking like many times at the end, I used to do collectors and group and then throw everything into a list, and or even more like after grouping, then expanding a little and expanding again to mapping. Until I got the desired form of the response. And now that we have stream gatherers, you make me think again of how I'm implementing things, and I'm thinking, I'm doing the right thing here? No, and maybe this intermediate operation, this chaining of things could be done with an intermediate operation, and I'm just collecting at the end when I'm happy enough with this stuff. In this case, getting to intermediate operation and needs, as you said, you didn't want to pollute the already present utilities and interface with too much, because then we will be searching the documentation for which the one suits our needs, and when there are too many options, again, it's not that good. Probably the part that everybody is interested in, because and I've seen it touched by some people in feedback and in presentations, and that I would like to see more. For example, the part where developers get the control, meaning making your own gatherer. So can you share how we can make our own gatherer, what ingredients we need for our own gatherers, and any tips and tricks?
That's a great question. So what I tend to do is to start from scratch. As I mentioned before, I ended up re-implementing the entire stream interface based on gatherers. And what made most sense for me was to try to start with what I considered to be the simplest operation. So I decided to implement map. So for each element, I apply a function, and then I send the result of that function downstream. And a gatherer is similar to collector in its API design. So you can think of it as an interface that has a set of methods that return functional interfaces. So it allows you to have this recipe of different behaviors at different stages in the stream processing. So first you create a potential state object that you want to remember while you're processing. And then we have what's called an integrator. And an integrator takes that state object, the next element in the stream, and then you get a handle to the downstream so that you're able to send elements down the stream. And then you have a combiner, as you do with collectors, to support parallel computation if you want to. The interesting design choice that we made with gatherers there is that it's actually optional whether you want to support parallelization or not. So collector forces you to have a combiner, and if you're running that collector in a parallel stream, that combiner should work. But with gatherers, you're actually able to say that this operation can only be run sequentially, because there are certain algorithms or transformations that do not lend themselves that well to parallelization in the first place. So this allows you to, if you want to create map, you don't need any state, so you don't need to remember anything between each element. You need an integrator, which is for each element, I want to do something. You might want to do a combiner here, right? Because map parallelizes pretty well. And then we have a finisher at the end, which is after we know that there are no more elements upstream, we get a callback to say, okay, we're done. And then you're able to get the state object at the end and another downstream handle. So you can say, okay, I know we're all done. Now I can send the remaining elements or do whatever you need there. And with map, you just need the integrator. And to specify if you want to the parallel combiner. So what I tend to do is to take these simple operations and see, okay, how do I implement the simple thing? And then I start with the next most simple thing, and I build up the more difficult operations. So I think it's always easy, at least for me, to start with something that is with few moving parts, and I get comfortable with the API itself, and then when I know that that works, I can take on bigger challenges.
Yeah, that's also been my experience with my own customer, because in the beginning when I tried to make my first one, I had like let's say I had a big goal in my mind to achieve with that, and then when going through making my own integrator and combiner, I was like, yeah, maybe I should like trim down a bit from the big goal and see how I'm getting this first one, and then I advanced a little further. Thank you for the tips and tricks. So like always start small and build for the greater stuff, like for everything mostly in development. I mean,
well, especially if you're learning something new, you definitely
Yes.
want to set yourself up for some incremental success along the way.
Yes, and then in the end, I mean, there have been a couple of iterations of stream gatherers, but there still is a new operation, and it will take a while until we get so comfortable with it as developers, like we are with the rest of the Stream API functionality. Okay, the next question from my side, because it's another curiosity of mine, chaining gatherers. So something that I personally miss in seeing as examples is chaining gatherers, like practical, like you said, you want to see more practical things of when you chain gatherers. And so first of all, maybe to inspire our audience, can you please explain what it means to chain the gatherers? What's this capability? And then maybe give some of your expectations where you see chaining gatherings as an useful aspect, and examples maybe.
Yeah, no, absolutely. So with Java util or Java, I think it's Java util function. You have the and then method that allows you to take an instance of a function and an instance of another function where the return type of the first one matches the input type of the second, and give you a new function that takes the initial value of the first function or the parameter value of the first function and give you the return value of the second function. And that's really powerful because it allows you to compose small pieces together that on the surface still look simple. It's still a function. You don't know how many functions are composed underneath. And Gatherer ended up, I don't know what the exact moment was, but I just realized that you could just plug them together without necessarily having any input elements or any destination of the elements. You could make a gatherer look simple on the outside, but it could be consisting of multiple gatherers underneath. So imagine that you were to implement map as a gatherer, for instance, and you were to implement filter as a gatherer. Now, if you have an operation where you just want to map certain objects and you want to discard the rest, then you should be able to just compose those two and return that as a higher level gatherer from your API. So that would allow you to create more sophisticated behavior, and you can still pass it around, you can still reuse it without having to, because if you couldn't do that, with collector, if you're building up a collector sort of from the end forward or backwards, really, like you're joining and collecting and all of these combinators, if you get an instance of that, if you couldn't reuse it, you would have to remember to do all of those steps multiple times and keep them in sync, right? So I think being able to compose gatherers together and return them or use them or store them in a static final somewhere or whatever it might be, you don't necessarily know what the underlying implementation looks like. It takes this input, it provides this output. And I think that's a really powerful abstraction. So, of course, I think the question is really good because when there are few gatherers, the value of composition is lower. But as the number of gatherers grow, the value increases exponentially, right? Because you can combine many, many things together in many steps. So I think what we'll see is that as time progresses and there are more interesting gatherers out there, we'll also see more of them being reused and composed, and I think that's an interesting take on this.
On the chaining gatherers aspect, so also from my personal experience with trying this feature, again, as I said, I tried to do a kind of complex operation for one of my demos. And my first instinct after getting comfortable with the interface was actually to dump most of the logic into the integrator and combiner, because I could do everything there with the functions, right? And at the end, well, I got one. There was one custom one.
Yeah.
And then I looked at so while I was calling the gatherer, it looked fine.
Yeah.
I looked at is this name that I gave for this complex gatherer meaningful to what it does? And I looked again to the implementation, but actually there are two, and maybe if I want to evolve this, and we all are interested in evolving our applications and what we're building, maybe it would be better if I split this into two gatherers and then I'm chaining them. So it's great advice for our audience, like when things get too complex with one gatherer, let's say your own custom gatherer implementation, it's good things to maybe refactor that in two of them, because as the already provided ones are with some utilities, you're building your own utilities for your own team.
Yeah.
And you should give those in a simpler way. And also, I think from maintenance perspective, keeping things simple is the best thing. You never know when you need those pieces with another gatherer that you build in the future. So it's very elegant and simple to work with, at least from my point of view. I really admire how the current interface is done, and kind of takes you to simplicity. So folks, if you have more examples about chaining gatherers, I think you can write blog posts or tweet about your ideas, because we would like to see more of those examples from the out world reaching out to us. Myself, I'm spending too much time on the internet probably, or maybe all of us. I've seen a lot of examples with already built-in gatherers, but I'm sure that so many more things can be done with the custom one. I've seen map by distinct done by people. These custom gatherers seem to work very well when you try to do distinct operations. Again, sliding windows are great when, like you said, we want to compare with what we had before when we're moving in through grouping something in our streams. There's so much that we can do with this. And what I'm happy is to see people at conferences talking more and more about what you can do with stream gatherers. So I'm looking forward to get more practices from the community and also from the experts of the community. So I wanted to ask you, you started by saying to people, if they have more examples, they can reach out. But I want to say they can reach out to us with the examples. We want to get more feedback. There's never too late to give feedback on features, and don't be shy to contact us. But I'm interested, okay, so we have now these already built-in methods. We have this great interface. Now I'm going to just try and see if you can tell me something about the future. Are there any plans to have more built-in gatherers or adding something to the interface? Can you tell us how this will influence some of the other future things and streams?
So I think what we want to do is to have a story for how does a new gatherer end up in the gatherer's utility class. And it's one of those things that is really difficult to decide what makes it useful enough or what makes it common enough. But I think it will hopefully be blatantly obvious that, of course we missed that, or we see that it's being used everywhere. So I think we want to have a story for new gatherers to end up there, or useful gatherers to end up there. I think from evolving the gatherer's interface itself, or evolving the capabilities of the contract, I think, so I spent a lot of time, of course, coming up with different types of, I mean, what we see here is the tip of the iceberg, really. I had many many prototypes.
Like in any, I think there's no API implementation that is perfect from the beginning, and I think our audience does the same thing in their daily job. You're excused from not doing perfect from the first time. So don't worry about that. But
yeah. So I think, with that said, there are many reasons why it ended up as it ended up, and I think I was trying to find the minimal complexity that still gives you the maximal flexibility in terms of your operations. So by re-implementing Stream for myself in my own experiment, using only gatherers allowed me to still prove to myself that it's still powerful enough and flexible enough to do everything that used to be on Stream anyway, but what do we need beyond that? So that was going into the windowing functions, the map concurrent work, the folding and the scanning. But I think that there are so many other operations like statistical functions or even more complex windowing functions, but I'm fairly comfortable with knowing that the Gatherer interface will support those, because one of the big things with streams is that you don't necessarily know how many elements you have in the stream. Otherwise it would just be a list or something. And being able to have these custom operations that still only consume what they need, so having this sort of short circuit signal to say, we're done now, we don't need to consume any more elements, it allows you to implement really, I mean, limit, for instance, which is one of those operations which might seem simple on the surface, but how do you implement limit if you need to consume the entire stream, right? How do you implement limit as a collector that doesn't have short circuiting? So I think I'm feeling comfortable with the way that it ended up. And so I don't see necessarily changing the Gatherer interface itself or necessarily adding anything there. Of course, I might be wrong. But I think the big promise lies in the new potential operations that might be extremely useful to people. But I think many of them might be not necessarily domain specific, but still specific enough to not warrant everybody having to scroll through a list of suggested endpoints. So,
yeah, I mean, that's when the part of the folks trying, of all of us trying and saying that, well, it would be so nice if this would be present there. And when, you know, it's like when more voices gather together, when more voices gather, there are more gatherers. But yes, like now it's probably the action is in our court, the end users, to say something upon this, to try things and voice it through, I mean, most of the time we don't voice it, we write it, like, this would have been so nice, it would have been there. Of course, always being polite to the implementer, because they've done a lot of work. I'm sure that there are a lot of people that are behind the feature that have worked on the JEP, that have supported the enhancement proposal. And yeah, many more people that are using it in the JDK. So
yeah, absolutely. I mean, I think that's a great point. I mean, I didn't do this work, right? I was only able to do this because of all the great work that was done before. So just as a frame of reference here, I mean, one of the first things that I had to do was to learn the entire reference implementation of Stream to figure out where can I actually insert this? How does it fit into what's already there? And of course, so much work over so many years on streams, on augmenting the interfaces, on improving performance. And so I think the key moment was when I found the place to make the incision, right? okay, so here's where we can actually, with minimal invasive operations, insert this completely new thing inside something that is already established and not have it be bolted on or something like that. So I think if I did anything, it was just to locate where to make the incision and and leaning on the work of others.
Yes, it's always like the case of great work of others can spin more ideas in the future, and it's great to see things evolving, even for an API that people might be like, but that's a done deal. It's been there since 8, so why now? But you see, folks, we are still gathering information from you and examples about how even the things already great and built in there can be improved. And it's also the case of sequence collections. We had collections done like that for so long, and then sequence collections. Because throughout the years, there's been a lot of feedback gathered that it would be way easier and way better for us to have another set of tools, another set of utilities and APIs with the existing API to enhance our experience when coding. So Viktor, I think we're kind of ending to our conversation. I want to thank you once again for taking your time to join me today. Well, folks, as we probably iterated a lot of times in this podcast, if you're keen to know more about what will happen to Stream Gatherers, if you want to contact Viktor and give feedback on Stream Gatherers, there's always mailing lists that you can reach out. People are very nice there. They're looking forward to seeing examples. We always are excited to see you writing to us. Don't think that you're just writing and nobody will read it. Trust me, people will read it. And we're happy to see both sides of the story, like happy stories and less happy stories. As we said, we always want to make things better for you. So that's one point of the conversation I want to take away for you, like besides the great tips and tricks from Viktor and how Stream Gatherers get to be the great API that they are today. But also, if you want to keep up with the latest news in Java, subscribe to our Java YouTube channel, check out Inside Java, check out the tutorials on dev.java to learn more on how to use the Java features. It's always good to have like a good reminder on what and on how you can do certain operations in Java. And yes, thank you again.
Thank you.
And folks, stay tuned for more.